Okay, so a quick recap. So before going to the exercise, so how is the progress? Any feedback from your side? All good, fine. How about others? Okay, from Raymond is good. Okay. Fine. Okay, so maybe quickly can we go through the exercise so that maybe after uh, maybe like after 5 or something we'll start discussing about the assignment. Maybe I can just show you an assignment. Okay, a sample assignment. Right, so that we have some activities and then we have some lab exercise. So tomorrow we can have one lecture class and then we can progress with the lab class as well. Is it okay? So this is what is our plan. Okay, thank you, Wong. So how about others? Okay, thanks, fine. Ong is fine. Raymond, Kong. Okay, fine. Okay, so hope everybody have tried to complete some of the things so that we can make it more faster, right? So these particular things I'll right. So all of you have completed all these things. So how about univariate? Did you complete the univariate one? You can just give SS so that we can just move it faster. Because I'm sure some of them maybe because of time constraint, right? Maybe you would have not have done it. No issues. We can just try to make it more faster or make it just we try to make it hands-on for the benefit of everyone, right? Because it's a part-time course, so we know the time constraints, everything. But even though we need to make sure that everybody is progressing, okay? So I just want to know that if these things are completed, then you can have more good progress in your assignment as well, right? So which covers all the learning outcomes. Okay, so is everyone able to complete the univariate plotting or able to understand the reason why we are using univariate to get more details about the variances in the data, the distribution of the data, right? The mean, median, mode can also be got. Okay, fine. If anybody is having any doubt, okay, please make sure that you put it over here so we can discuss. And if anybody also having the screenshots, you can put the screenshots here so that we can know that periodically progressing, okay, and parallelly progressing. So univariate will give us these details, right? The mean, the variance, skewness, the basic statistical measures, the test, right? So I'm sure all of you are by now, right, make sure that you're a little more aware of the statistical details, because when you are in data science, right, you should know some details of the statistics. And I'm sure like the prerequisite is something dealing with statistics. So just make sure that you are a little more aware of these things. So in quantiles, right, we are trying to get the details about the quantile values. Okay, So here you can see what is the max and the min value. So regarding our data, so the data is 2, 5, 9, 9, 10, and 11. So max value is 2. Sorry, the max value is 11 and min max value are getting it like 2 and 11, right? So we're getting the extreme observations, lowest and the highest, right? And the distributions. Okay, so are we clear in this distribution? So this plot, what we are having is the bar, and as well as we have the box plot. Right. Okay, thank you, Tan. That's really good. I really appreciate. Okay. So how many of you are aware of this box plot? Is anybody new to box plot? Or anybody already have a good knowledge about box plot? Okay, you can just put your feedback here. We can have some discussions. Okay, Raymond is very new. Okay, Praveen, no issues. Fine. Okay, so if in case I remember there was one particular picture that was put over here, right? Last class, I think it was from Ong. Ong, you remember that picture? The interquartile range.
That one is not put one, but it's asking you about the box plot, how to interpret it.
Ah, yeah.
Thank you, sir.
You can put it over here. Once again.
Okay, I try to put again.
Okay. Right. So here we are trying to get an understanding about the data dispersion. Okay. So meanwhile, we'll just try to go over these details. So I think we do have some details over here. Just check periodically. Okay.
So I posted the box plot chart already.
Oh, thank you.
Thank you, sir.
Okay. So meanwhile, I just want to make sure that we are making us aware of the dispersion of the data, right? So because we're talking about data management, we should. Okay, not this one. Okay, no issues. I'll get it from the net so that it's more easier.
So are you referring to the in something like that one? I posted in the chat already.
Just the right time. Very good. Okay, because this will give us more clarity. All these things are basically statistical things. Okay, so if in case somebody is very new, then it's no issue. We can discuss on these things. Because it's always said, a picture is worth 1,000 words, right? That's very aptly said. Because when you have a picture, what really happens here is it gives you photogenic memory to be activated, which makes it more because this is very important. Okay, so you have very much data. Okay, so start sharing the screen. Okay, to go with this first, right? So we're just trying to bring us understanding about the box plot, right? Before going in detail about what are these quartiles actually. So the box plot, okay, I'm sure all of you are getting this right, the screen.
Yes, sir.
Okay, thank you. So the box plot actually, the name suggests it's from the two persons, right? Who invented this, okay? And so the box plot also suggests something like the box which gives us a detail about the data dispersions, right, and the validity of the data in terms of the mean, median, mode. Okay, so here we have the min and max that has been given as the whiskers, okay, and the interquartile range, okay, which is the whole box as such, and then we have a median which divides the box, because we know that the median actually gives us the exact half of the data that has been given to us, right? So sure, all of you will understand the difference between mean and a median, right? So the median actually divides the data as a two halves, right? Whereas a mean will give us the average of the particular data set actually. So Q1 gives us the lower quartile and Q2 is what is called as the mid range, right? And Q3 is our upper quartile. So this is the box as such, right? So we need to go with detail about what is this quartile all about. So this is once again another diagram from Kong, right? Thank you, Kong. So this is what we discussed in last class. I think we discussed saying that okay, we'll have to have this more discussion in the class when we have details about the univariate thing. So this is app time we need to discuss these things. So please take a very good note of the technical terms. So here we're talking about interquartile range. We're talking about outliers, right? And Q1, Q3 as such, because we need these Q1 and Q3 for getting the formulae, right? And this is also a part of your assignment task where you have to get the outliers, right? And you need to use these formulas. Okay. Anyway, we will discuss those with a small code, okay, with a small snippet about how we go with getting the outliers. Before that, we need to go discussion about the statistical details. Right? So the minimum is about the outliers that is actually less than the minimum, right? We have the minimum value and the maximum value for a given data set. And for our data set, we said that the min value is 2, max value is 11, right? So if there is any value, right, which is less than the particular range, we call that as an outlier. Similarly, we can have both max outlier and minimum outlier. That is only calculated only after we go with this interquartile range. That is the reason why we go with this interquartile range. Now, this is actually calculated with values of median, right? And the 25% of which is less than the median, okay, is portrayed as Q1, and more than the median is portrayed as Q3, right? Okay. So this is what we are trying to discuss. Okay, the middle part, which is 50%, is Q2, right? The lower 25% and the upper 20% is Q1 and Q3 as such, right? So this so all of you can see this value. So when you put it in a normal distribution, this is how it looks like. So here we can see what are we trying to discuss, right? The bell curve gives us a very good understanding about the distribution of the data, right? So the lower quartile, which is the Q1, can be found out with this value 1.5 cross IQ R, and Q3 can be calculated with this particular formula. So you are trying to get the outliers, which I'm going to give you as an example or the code, okay, where you can easily understand that. I'm just giving you this particular diagram for you to visualize how we are trying to put them under the graphs, right? So the IQR, the median, Q1, Q3, right? And then trying to get the outliers. So with data as such. So if in case we have a value, always it is suggested, right? It is very important that we need to arrange or sort the data. So that is why we have one particular function called sort, right? So we need to use the sort function to sort our data. Once the data is sorted, right, in ascending order, then we can go with this particular functionalities, right, getting the quartile values. So you can see the 50% range gives us the IQR, right? And the lower 25% is called as Q1, and the upper 20% is called as the Q3, right? And what is Q2? So the question now is, what is Q2? Is Q2 mean or median? Can we get it in the chat? Is Q2 mean or median? Very good, right? Thank you. So this is another interesting box plot, which gives more detail into our understanding, right? So we discussed just now about what is median, right? Okay, which actually divides the whole data set into two, right? Because median is the exact center, right? Based on the odd or even number, we can calculate whether it is going to be which particular type of a range we are talking about. So median exactly divides the data set into two. Mean is going to get the average. Okay, so in the box plot, mean is provided as dotted lines. Median is provided as a thick line, right? Okay, and the 50% value is our interquartile range. Q1 is our lower quartile range and Q3 is our upper quartile, right? So the box indicates the range in which the middle 50% of all data lies, right? And you can also see one particular dot data point that is actually moving away from our max, right? So mean is without outlier, max is also without outliers. We're trying to identify them, and those that actually doesn't fit into this boundary, we call them as outliers. Okay, so thus the lower end of the box is the first quartile and upper end is the third quartile. So between Q1 and Q3, the interquartile range is thus provided. So in the box plot, the solid line indicates the median and the dashed line the mean. Okay, the T-shaped whisker, okay, which you can see both the bottom and the top, goes to the last point, which is the still within 1.5 times the interquartile range. So that is where we are going to discuss about the formula, right? Formula to identify this range. Okay, so points that are further away are considered as outliers. So for now, please make sure that you're able to justify this box plot. So regarding the formulas, we'll be discussing still more when we go into some more of the examples, right? Are we clear now? Are we able to get some more clarification of this box plot? Yes, class? Any doubts? KG is fine. Okay, that is clear. Praveen, what about Ang? Ang Pao, Lee?
So
Trisha just
still
joined. Very good.
still
Yes, Ang.
digesting on the I mean we actually exporting out the box plots using SAS, and then I try to understand it using SAS perspective. So I try to bring that knowledge and then how to study that things.
No issues, because anyway we'll be doing that.
Thank you, sir.
Okay, we'll be discussing those different plots. Okay, and also we'll be having some codes to identify the outliers and all those things as such. Okay, maybe using the same data set if in case. Okay, some minimum lines of code. Okay, so that it executes in a fair way, okay, not taking much time, and also you can also understand how you can go with your own data set as such, right? Okay.
So actually, I copy one of the chart from Chai Ju Kang. I just want to ask you, that's a middle, that's a something like a square like that. That one is a median or mean? It's a median, right? Mean, right? The square in between.
Deviation. Standard deviation.
Standard deviation. I'll say. Thank you, sir.
Okay, thank you. Okay. Actually, there is one particular website called. I'm not sure how many of you gone through that. We call it as Data Labs. datalab.net. Maybe you can just explore a little later. Okay, so there it gives you more interesting statistical details, right? Okay, but some of them are free, some of them maybe it needs some sort of an what do you call as membership. Okay, you can just explore them if in case, just to get more statistical details regarding the data. Okay. So now I'm sure all of you are very clear with the reason why we go with the univariate, the proc univariate, right? So it can plot the data, right? It can give the first data's plotting as well as get us all the details regarding the particular variable y, right? Okay. Next. Anyway, I just want everyone to just make sure that you're also getting your hands on with the SAS, okay, so that you don't feel any difficulty later. So here this just to make sure that if in case there is any error, what will happen? Like, so if in case you don't use a semicolon, missing semicolon, right? So you can use your log. Right? You can use your log to check for any errors in case there's something like okay, in case executing it. Right, and then you see some errors, right? You can go to the log and then check what is the real problem. And you can just see here, it is just trying to give us some data. The syntax error, it has to follow with semicolon. So just for us understanding, right? Okay, good. Similarly for all the other cases. Okay. Okay. How many of you tried this one? Data. Okay. And did you use infile? Did you try to check with infile? Were you able to get this?
So I try already. It seems like not working.
Okay, good. Okay, so how about anybody who just tried any other method to get it working? Okay, no issues.
So is it the code that using the infra one, we need to install a desktop version of SAS instead of the on the cloud SAS?
Yes, you're right.
Thank you, sir.
Right, Hang is right, because we need to have the desktop version of SAS because we're using cloud. Okay, but what's the other option?
Import the data first, and then after that only convert into the data set.
Yes. Thank you, Tan. So Tan uploaded the file into SAS. Okay. What are other steps, Tan? That's the reason why I'm saying that we have many experts here, so we have some good discussions. Yes, Tan. After upload, you get your file name, right? You get the file path. Because you'll be uploading to one particular folder that you already created. Once you upload it, you will get the file path, right? Yes, but once again, here you are using infile, right? Okay. So will that work? Is it working? Okay, can you give us the output? Because we still have a good method. That's also a very nice approach. Good.